Hey, year sevens. Today we're going to talk about theoretical probability. So when we talk about theoretical probability, you can calculate the chance or the probability of an event occurring, and we do this using a fraction, a percentage or a decimal. But mainly for today, we're going to keep that to a fraction. And a couple times we might talk about moving to a decimal, but overall we'll talk about it as a fraction for today. Some parts of today's lesson I'm going to try to make sure that I'm going nice and slow. It's going to be tricky because we will come back around to the fractions, percents, and decimals concepts in later topics, but for now I'm just going to try to keep it to things that we've done. So when we talk about probability, I'm just holding my finger on the screen here so we can talk. We have a concept called PE, and so what PE means is it's the probability of an event. So the P is a probability, and that's a probability of an event, what is inside the brackets, and what's the probability of that event happening. So PE can be thought of as the number of favorable outcomes or the outcomes that match what we're looking for versus or over the total number of outcomes. So we can talk about things like the probability, if we're talking about coins, the probabilities of heads being tossed. The other way we could write that would be the P of heads. And that would be that. If you were talking about dice, you can talk about the probability of rolling a 6 or the probability of rolling a 3. And that would be how you would write the probability of something happening. You'd write the P for probability, and then you would include brackets and then what the probability is of what we're talking about. So let's look at a couple ways of talking about this and practicing this. So for my first example, we're going to find or represent the probability of rolling different situations. So our first situation, what is the probability of rolling a 5? So the first thing we want to think about is we write P bracket 5 because we're trying to figure out the probability of getting a 5, and this is for A. So the next thing we're going to do is we represent that as a fraction. So remember, I have a fraction. On the bottom of it, we have to figure out the total possible situations. So for the bottom, down here, this is going to be the number of sides of a die. Okay, so what is the number of sides on a regular dice, which I have right here? Well, we got 6 sides. So on the top, what we're going to look at here is the number of those sides that are a 5. So how many of those sides contain a 5 on it? So only one of those sides have a 5 on it. And so this would be the way you'd represent the answer. If you wanted to make it look nice without all the curly brackets, you would only really write that right there, and that's what you would be writing. So let's do B. I've kind of been crowding B, so let's do B next. I'll see if we can kind of keep some room here for C in a bit. So B. So we again start out, what is the probability of rolling a 7? All right, well, what is the probability of rolling a 7 on a 6-sided die? It's going to be a 0, and you're probably like, sir, how'd you figure that out so quick? Well, remember yesterday's lesson, we talked about that line, and we talked about probability on it. Over here, we got 1, which is certain. Guarantee that something's going to happen, and at this in the line, we got 0, which is impossible. It's never going to happen. So certain is 1, impossible is 0. So if we know that it's absolutely impossible to roll a 7 with a die, the probability of that is not even be a fraction, it's just 0. You can also think about it as 0 over 6, which is also just 0. So that's for B. So your probability would be 0. There's a 0 chance of it. There's a 0% chance of it. There's no way that is going to happen. So next we're going to look at an odd number. So when we think about our odd number, we can think back to yesterday, and we started talking about the sample size. So yesterday, in a video that I had given you, we talked about sample space. Right here, that's sample space. And in our sample space, we're going to figure out our sample space. So first we got to think about all the different numbers on a dice that are odd. So that's going to be 1, 3, and 5. That represents our sample space. So that would be all the possible combinations that are odd. So next thing we can do is now we can figure out the probability of rolling an odd number. So now we take it, and we know there's 6 possible sides, and 3 of those possible 6 are odd. Now we can reduce that fraction. We know that 3/6 is also equivalent to 1/2. You know, you get 3 to the 6, it's also equal to 1/2. So I've reduced my fraction down. We'll spend some time talk about this more in time if you need to. For right now, just because of the way things are going, if you need a calculator to kind of simplify that down, that's also okay as well for now. So for D, we're going to look at the number less than 3. So again, we're going to look at our sample space. What are the numbers on a dice that are less than 3? So do we have a side that's 0? No. We have a side that's 1. A side that's 2. And is 3 less than 3? No, it's equal to. So we do not include that. So now we're going to figure out the probability of rolling something that is less than 3. So that's your sign for less than 3. The mouth is pointing towards 3, so that means it's a larger number, so we're trying to figure out anything that's less than 3. That's going to be 2 of our possible 6 sides, which can be reduced down to 1/3. And that's the probability of rolling a number less than 3, so 1/3. Let's look at our second example. So our second example, we have a jar of lollies. Our jar of lollies has 5 red, 3 green, 6 yellow, and 2 blue lollies. Taylor selects 1 lolly from the jar at random and notes its color. Calculate the probability below. So before we get started, remember we need to figure out the denominator, the bottom of our fraction. We need to figure out that total amount of lollies that we have. So we're going to add them all up. So what we're going to do is we need to figure out our total number of lollies. So just let me erase a couple things there. So we need to figure out our total, oops, there we go. We need to figure out our total number of lollies. At home we'd call them candies. So that would be 5 for the red, 3 for the green, plus 6 yellow, plus 2 of the blues. And that cuts us to a grand total of 16. So now we know how many lollies are in that container. We got 16 total lollies in our container. Okay, so now we're ready to move forward. So I don't know why I wrote square there. Let me just erase that. So now we know how many lollies are in our container. So now we're ready for A. So if we're going to do A, we're going to figure out our probability of yellow. Again, we write our total number of possibilities, our total number of candies on the bottom, which is 16. And then how many of those are actually yellow? 6 of them are yellow. Now, this is where having talked about fractions before would help. Because these are both even numbers, I know I can divide them by 2, both of them, to reduce them down to the smallest number. So I know that if I divided them both by 2, I can reduce or simplify that fraction to 3/8. So that's the probability of rolling, or sorry, of selecting, not rolling, of selecting a yellow lolly would be 3/8. Go on to B, a green or a blue lolly. So what we do is we look at how many green lollies we have, which is 3, how many blue lollies, which is 2. So I know that 3 plus 2 is 5, so the probability of a green, so that's an ugly looking G, green or blue is equal to 5/16. And we can't reduce that any down further, so that's as far as we can get it. I'm going to erase some of my stuff here just to make a little bit of room, so that way I can kind of continue doing my examples without starting a new page. You already know how I got 16 for lollies. So for C, we're going to determine how many of those lollies are a traffic light color. All right, I'm not going to worry about the percentage part, but we're going to worry about the traffic light colors. So of the traffic light colors, I believe things that are traffic light colors here would be the reds. Ooh, that's not as see-through as I hoped. Let me just try one thing. Let's see, opacity. Let's make it a little bit more opaque. So it would be red, green, or yellow. So those are things that would be opaque. Or sorry, not opaque, traffic light colors. So our probability, I want a black pen. Our probability of a traffic light color would be equal to, so we're looking at the 16 total. So what's 5 plus 3 is 8. And 8 plus 6 gets us to 14. So that's our probability of a traffic light is 14 over 16, which can be reduced down if I divide them both by 2 to 7 over 8, and I've written it in its lowest form. So D, it says the probability of not red. So I need to figure out my probability of not red. Okay, so probability of not red over 16. Again, I need to look at my total colors, and I need to then think to myself, okay, so what of these are not red? So I've got red right there, so that's going to be everything else other than the red. So it's going to be the green, the yellow, and the blue. So I'm going to add 3 plus 6 is 9, plus 2 is 11. So I just quickly move over here, and that's 11 out of 16. There you go. That's basically lesson for the day. I hope that helps you with your work, and I'll be posting that up next. Take care.